Now it's my pleasure to welcome Pete Bernard, Senior Director of Azure Edge Devices from Microsoft, up on stage. We're going to talk about 5G and machine learning and IoT and cloud and so many interesting things. Please, welcome.
Is this on? Yeah, I think so. Good.
Check, check. Sounds
Excellent.
good. Yeah.
All right. I was, I think I had mentioned this is, like many of you, this is like my first, 3D experience in about a year and a half. And I was telling someone this morning, one of the interesting things was I needed to put shoes on today. And I bought these shoes like 6 months ago. I hadn't worn them yet, so I'm pretty excited about being at a place where I need shoes. So that's good.
The simple pleasures in life now are what matters.
Put my shoes on.
So Pete, thanks for joining us.
Sure.
I, myself, am super fascinated by what happens in connectivity in edge and cloud and how there's so much pushing workloads here and there.
Right.
It's fascinating, but it's also super confusing for all of us.
Right.
So I hope at the end of this, we have an even better understanding for everyone, where these things are going. But let's start talking about applications in the IoT space. What gets you excited about machine learning and IoT?
Yeah, so it's interesting. I mean, sitting through some of these talks, like the last talk from Zach I thought was great, and hearing Ray this morning and stuff is fantastic. And it's really interesting to hear from different people's perspectives, right? Because there's, if you're a device builder, you're thinking about how do I kind of keep my power low and my costs low, and how do I get to the cloud? We're a cloud. I'm coming from the cloud side, right? So we've got these 60 hyperscaler data centers around the world, and we're thinking about how do we get developers to develop solutions on our cloud that actually reach the edge. It's kind of heterogeneous edge, right? So it's a little different way of thinking about things for us. Yeah, I mean, it's definitely an interesting way of, the challenge really is the heterogeneity, I guess, of the edge is really what's challenging, right? Because you've got tons of incredible semiconductor tech out there that's coming out every day. And you've got security issues, you've got manageability issues. I mean, Zach was talking about, OTA, seems kind of simple, but it's actually incredibly difficult, especially to do securely. And so, from a cloud provider perspective or a platform provider perspective, we have to sort of think about how do we enable developers to do that without sort of reinventing the wheel, right? And do it across solutions. And solutions usually involve more than one piece of equipment, right? And so you may have some, moisture sensors out there, and some AI vision gateways, and some cameras, and some heavy edge equipment, right? And again, with all different silicon and different platforms, and how do you run that and manage that from the cloud? So that's kind of what's been keeping us busy.
And we clearly see that something magical is happening here with edge and machine learning, right? Mm-hmm. We see it from the developer excitement, the companies involved building real applications. But what do you think is pushing these machine learning workloads towards the edge? What's the fundamental math that's
Yeah, it's interesting. So we have a bunch of kind of first-party AI models. We do a lot of, Azure ML on the cloud is a big business for us. We've been doing it for a decade. And there's some incredible things you can do when you have some, hyperscaler compute power, right? When you have a football field full of NVIDIA T4s, you can run some pretty cool models. Can't really do that, on the edge. And so one of the things we think about is what are the workloads or the models that are more appropriate to run on the data center in the cloud versus maybe outside the data center but on a piece of heavy edge equipment versus in an AI vision camera itself versus on an MCU-based sensor. And so what we're seeing is, different workloads need to be run at different parts. It's almost like a tiered system of workloads, right? Depending on the compute power you have and the job that you need to get done. So some people are saying hey, I want to do a lot of AI vision at the edge, and I don't want to overload the network with a lot of streaming data. I don't want to have privacy issues, so maybe I want to keep things kind of obscured a little bit on the edge. Or maybe I want to do something in real time, so I don't want to have to get any latency involved. So those are some of the things that would drive workloads more toward the edge. But also, you have that other problem of, there's never enough sort of TOPS available for the workload that you want to run. And I think that's one of the things over the next probably 3 to 5 years we'll see a lot more innovation to run either more high performance models further out on the edge.
Right, so do the work to optimize and put more and more towards the edge. And so really user experience for the developer, I guess, like they want to do a complex model, we should make that happen, right?
Yeah, I mean, I think the challenge for the developer, like, we come at it from a solutions perspective. I think, especially in the IoT world or the edge world, the solution is sort of a canonical unit of measure, right? Because when you talk to a Chevron or a Chipotle or whatever, they want to solve a problem. And so, we think about, when a developer has to then solve that problem, how do they, figure out the right topology, right? What needs to get connected and what level of tiers, and then how do they write applications that can be managed and deployed over these different tiers?
Yep.
Right, so you get back to this other thing around, super heterogeneous pieces that are all connected, and how do you get that code to run? Even things like AI models, how do you get them optimized for, there's an NVIDIA piece over here, there's a Qualcomm piece over here, there's an NXP piece over here. How do you get all that to work? And how do you update those models? I mean, to Zach's last point, how do you update things? So.
And we heard something earlier, really interesting from Z, from Aura, where they're having to think about where do you distribute pieces of these algorithms on the ring, on an app in the cloud.
Right.
How do you think about the distribution of machine learning between edge and cloud? This is something we hear from customers all the time, like, oh, we're doing stuff in the cloud, and now they kind of think that they have to move all their workloads to the edge. And we're going like, no, only where it makes sense, right?
Yeah, and again, that's where you have that trade-off of, how much horsepower am I working with on the edge? What can I run? I mean, there's some models that we have, like we have a really cool spatial analytics model that can look at where people are walking and do all kinds of cool stuff. That needs like, NVIDIA T4 power, right? You cannot run that on a Cortex M. You can't run it on your ring.
Yet.
Not yet. But, and so it really depends on what problem you're trying to solve, right? If you're solving a pedestrian analysis thing, you're gonna really probably need to run that on some heavy edge equipment. But then if you're looking at, and I think Ray was talking earlier about, well, I wanna do a low power kind of vision sensor to detect if something's there or not, almost like a PIR. That's a 10 kilobyte model you could run at the far edge. So it really depends on what are the problems you're trying to solve, and how much horsepower do you have available, right?
Now, let's talk a little bit about the role of connectivity. I think this is really important for all of us because it's changing so fast. We've talked a lot about LPWAN, right? LoRaWAN, cellular IoT so far here. And that's pretty clear, right? You have such a small pipe.
Right.
You're not sending any raw data to the cloud, right? You've got to do ML.
Yes.
But 5G is coming, and this is something you spend your days thinking about in the Azure team. What is 5G going to mean for machine learning?
Yeah, so what's interesting about 5G, and we kind of tuck LPWA under 5G as well, but this kind of thing. But it kind of like when you get into a ultra low latency, like high bandwidth connection, it almost like sort of collapses the cloud and edge together, right? So now you're thinking of 5G almost like wireless fiber in some cases. And so your heavy edge equipment, even though it's a few miles away, is almost like it's just right there, right? So now, like going back to the example of where do I run my workloads, like I can now run my spatial analytics workloads, even though I'm using heavy edge equipment, pretty much like on site, right? Even though I don't have the equipment there because I'm using like some millimeter wave 5G to actually make that connection. So what we're seeing is that 5G is enabling some really unique kind of value propositions when it comes to ML and AI, and it's enabling customers to think about running much more powerful AI in kind of, I would say, deploy anywhere, almost anywhere at this point, if you have the right connection. So that connectivity can really be something that really changes what's possible.
And I find that fascinating because it means that we need to think even more broadly as the people creating tools to help developers deploy these workloads, that it's not even so clear cut that are we limiting ourselves to deploying on edge compute.
Right.
Maybe we should be allowing developers to easily deploy to cloud compute as well.
Yeah,
right? Because
exactly.
you never know where you might end up.
Yeah, and so one of the things we've been working on, and I won't push a lot of Microsoft products, although today I guess Microsoft Paint was updated, so I heard that was pretty exciting. But there's something called Azure Percept that we introduced back in March, and that's really like a set of Azure services and some reference hardware. Of course, you got to have some hardware to enable people to sort of speed up the development and deployment of edge AI solutions, including solutions in the cloud. So we're thinking about it more as like a fabric for developers where your workloads can, run on the Azure data center, maybe could run on Azure Stack Edge outside the data center, or maybe could run on a Myriad X-based, AI vision camera. So we're trying to kind of stitch together. I think another thing I heard this morning, Ray said, like, complexity kills, right? So we are trying to take a lot of the friction out for developers to think about AI workloads as being a lot more fluid between the cloud and the edge. And so that you can sort of tune your solution depending on, the ROI and the capabilities and connectivity that you have.
So it's kind of like tying up all the bits and pieces of interesting work that Azure's been doing with edge over time, like Sphere type of security management. I noticed that's
Right.
part of Percept.
Yep.
IoT, so communicating down the results, right? Because we get results from our machine learning models. Where do we put them?
Right.
We've written a couple really interesting developer case studies, examples with Edge Impulse and Azure IoT.
Right.
But also, right, getting into the edge compute, like containerization itself, which I think is
Right.
really cool. How do you manage those workloads, right? We can produce the workloads, but how do you manage
Yes.
containerizing them and distributing
Yeah,
them?
and that's where like there's some really cool stuff going on with like Kubernetes and Azure Arc and some other things where you're basically just kind of creating these VMs that can run, whether you're on the cloud or heavy edge equipment, and you can sort of move things around under sort of one management framework, right? I mean, we're not there yet on the light edge, right? But I mean, like you said, over the next few years or so, we'll get there. And so you can imagine that developers and operators of these systems will have a lot of these kind of tools available to kind of deploy and manage and update these VMs all the way to the far edge. That's pretty cool.
And earlier, we started looking at the kind of breadth of the market that we're working with, right?
Right.
We're looking at everything from industrial applications to enterprise and asset tracking, entire healthcare systems, really all of our hidden compute world, right? What is it going to take for all of us in the industry to serve those many applications with machine learning, and whether
Right.
we're deploying in the cloud or the edge? What does the kind of value chain start to look like around this?
Yeah, it's a good point because there is a lot of, I wouldn't say bespoke, but there's a lot of heavy lifting going on right now to solve some of these problems. And I think, over time we will start to, build on each other's platforms, right? So that, ultimately, if I'm working for McDonald's or something like that, maybe not making hamburgers, but in the back room, I'm able to, use some business logic and some applications, and buy some fairly off-the-shelf equipment, and be able to solve some problems. But that's there's a lot of friction in the system that we're trying to take out of the system. Right. I think with things like that we saw today, a lot of folks are bringing more modules, like cellular modules. Even in the 5G space, we're seeing some pretty cool USB-C based 5G modems out there. You can just kind of plug into your gateway and you're off and running. That's becoming a lot easier to get connected into those things. So I think it's just over time we're sort of building on each other's kind of PaaS, offerings, so that ultimately the business that needs to solve a problem doesn't have to sort of go bare metal, and write everything from scratch over again.
Amazing. I think there's a role for everyone. I agree. I think there's so much business to be had here, from modules, right, to complete vertical solutions where you build the entire thing,
right,
to system integration, engineering services. There's so much work for all of us to do.
Yeah.
I think our challenge will be keeping up with it, right?
Yeah, I mean, there's no shortage of work to do, right? And we meet with customers on a daily basis. I'm part of a team that runs our semiconductor partnerships and our telco partnerships. And as part of that, I get pulled into a lot of meetings, and the typical meeting is some Fortune 500 company that says, how can I use 5G to speed my digital transformation? Yeah. And I have my standard pitch deck. But what's amazing is each one of them has a very unique set of problems that they need to solve. And I think someone mentioned it before, even if you have a complete vertical stack, the first customer you bring it to is yeah, I like that, but actually I need to change this part. Yeah. And so, it is really a team sport. And we need to really make sure we have strong partnerships and some, pretty clear ways of interoperating with each other. I mean, when I'm working with telcos, telcos are typically a multi-cloud solution, right? So they're working with AWS and GCP and Azure, right? And so we all have to sort of figure out how our stuff's going to work together and ultimately serve the developer. So the developer is, not taking 18 months to solve a problem. They're taking like 3 months or 4 months, right? And that benefits the ROI for everybody, right? Everybody gets paid a lot faster if we can take the friction out.
And how do you see the role of the operator? I think that's a fascinating way of us to maybe get help going to market.
Yeah.
How will the role of the operator grow as machine learning on the edge grows, right, as a market?
By operator, you mean like the AT&T operator?
The telcos.
Okay. Yeah, so it's interesting. There's a lot of telcos these days that are, have invested whatever, their billions of dollars in their 5G network. And, you can only sell so many smartphones. And so now they're saying, well, we want to be a solution provider and include 5G and LPWA as part of our offering. So now they're, like one of the ones I just, I'm going to do this presentation, I've recorded it already for the TM Forum, and we work with Telstra in Australia, one of our big partners, and they're a big solution provider in Australia. So they go out there and they solve problems for the city of Sydney for their water system or whatever. And one of the projects I talked about that's now public is we're working with them on basically creating digital twins and kind of AI vision systems for their 5G cell towers. So they have like over 10,000 cell towers across Australia. And one of the interesting problems they had to solve was, and I know we're going to talk about wildlife in a minute, Sarah's going to talk about that. But turns out like cockatiels in Australia love cables. They like to chew on cables. And so we work with them on this POC where they can use AI vision cameras to identify cockatiels and kind of scare them off or whatever and keep them from chewing the wires on the 5G cell towers. So again, kind of unique problems, but a company like Telstra, you can throw in, AT&T, Verizon, I think they're going to be solution providers in and of themselves. They'll be able to bring their network with them to help solve some of those problems. And so, we should definitely be looking at them as like really kind of a unique combination of technology and assets to kind of go to market with.
I completely agree, and we need all the help that we can get going to market. So call to action for everybody. Remember, tomorrow, during our workshop day, we have a Microsoft-led workshop I think everyone should attend. The world's first artificial nose, using TinyML to train a VO gas sensor that looks at all the different gas particles and identifies what material is there based on its smell.
Yep.
And so everyone will learn how to make this themselves using hardware and different services. So please attend that workshop tomorrow.
That'll be good.
And Pete, thank you.
Yeah,
Thank you for attending.
Thanks.